Hey guys, Zach here again, and we're going to do another very interesting topic today. That topic being polynomial factorization. So let's quickly go through a lesson breakdown here so we know why we're doing and how we're going to do it. The first one we're going to do is look at the goal of factorization. Why are we doing this? The next thing is we're going to use the remainder and factor theorem to find us our first factor, and then following that through with synthetic division to find the last two factors. All good? Let's roll. So the goal of factorization is to take a standard factor polynomial, the f of x cubed function you see in front of you now, and finding its factorized form, i.e. the brackets. Notice there, each one of these, if you multiplied them out, would produce the function that you see above us here. And that's the real reason we're doing this. It's so we can gain very interesting insights into our functions. So the first thing we need to do is use the factor remainder theorem. And the factor remainder theorem states that if we've given a polynomial like this, f of x, and it is a polynomial, and that f a x plus b is a factor, then it'll hold up to the relationship I've just underlined. That means that if I plug it in as a minus b over a, as it's stated there, that'll produce a 0 in the function. So let's quickly use this as an example. The factor we saw earlier was that earlier x minus 1 we saw was a factor of this function here. So let's see if it really is, using the factor remainder theorem. So the fraction we have below us here is minus b over a equals 0. And sorry, not 0, equals minus times minus 1, which is the b value here, over 1. That all equals 1 at the end of the day. So nice and easy for us to take the first step. So f of x at 1 equals f of x cubed minus 6, 1 squared, plus 11, don't forget these. This is where we'll lose marks, is making careless errors like that. So keep in mind your signs, your squares, your cubes, keep in mind where those are. So quickly rewriting that, x 11 times 1 minus 6. So let's quickly rewrite this. If you guys want, work along with me on this section so that you guys keep speed with what I'm doing so that you know what to do. So this gives us 1 minus 6 plus 11 minus 6. So this plus this is 12, and that minus 6 means that it's 0. Therefore, at the end of the day, x minus 1 is in fact a factor, as we saw earlier. So let's do another example quickly before we move on to synthetic division, which is the final goal of what we're doing. So this has, at the moment, is x minus 2. We want to see if that's actually indeed a factor of this very interesting quadratic function we have here. So let's first find our b over a function quickly. So it's minus 2, because don't forget it, it's a minus and a minus. Very careful, don't forget that. Very simple to do that. Then you have your a, which in this case is 1. So that means our fraction is 2. I know it's convenient for me to get those examples, and you'll probably get a weird example in the exam, but just follow the method. Even if you do get a weird answer, it'll still work out. So let's plug in that 2 quickly and see if in fact this x minus 2 is a factor. So we have 2 times the factor 2 squared minus 5x, which in this case is 2 plus 2. Check your signs, that plus, minus, plus. Okay, everything's put in perfectly. So let's see what we got. This is a 4 here, and that's times 2, and that's 5. Don't forget that's a minus there. So that's 5 times 2, it's minus 10, and that's a 2 as it stood there. Careful with that sign as you saw me right there. I'm just doing it for demonstrative purposes, but don't write it there because you might get confused. So this gives us 8 minus 10 plus 2, and that whole as you can see, these two cancel with that, gives us 0. And Bob's your uncle, you're done. There's your factor and you know it works. So let's now see what synthetic division can do further from what we've just worked out. As you've seen, we found that x minus 1 is in fact a polynomial factor for the given polynomial. So now you might be asking, how do we use synthetic division? And I'm so glad you've asked that, because that's exactly what I'm about to give you. The first thing you do, and most importantly, is draw yourself a nice straight L, or inverted L in fact. And then from there, you transfer the coefficients of your cubic. And remember, this cubic could be any degree. Degree being the maximum power that your highest x has. So in this case, we have 1 from the x cubed function. We have minus 6 from the x squared function. We have plus 11 from the x, and then a minus 6 from the constant. We then take in our a over b, minus b over a function here, and plant it right here, which in this case we know was 1. And then finally, you drag your 1 down. That's your starting point. Once you're here, the magic really starts happening. So let's go through it together. So what you do, the first step is always this one times this one added to this one. So let's quickly do that. 1 times 1 is added to 6, so that's minus 5. There, minus 5 is timesed again by to 1, and that produces minus 5. That produces 6 at the bottom when added to the 11. And there we go. We're starting to really build up that momentum. That 1 times 6, bang, gives us positive 6 and 0. And what do you know? There we have our final thing. And you know you're right because that 0 is there. That 0 is your check for this. That's your mark guaranteed. So let's quickly rewrite this in what we understand. This is the x squared term. This is the x, and this is the constant. So let's quickly rewrite this in terms of f of x. So f of x equals x minus 1 times, this is your x squared value, this is your x value, so it's minus 5x, and then here's your 6 plus 6. And bang, there's your first factor. Now you'd be asking, but that isn't the final form. We saw earlier that there were 2 other terms, and you'd be damn right for saying that. How you get to that is using your easier, or you have a few ways of doing that. We all know how to factorize this further. You can use your quadratic function, as you've stated at the bottom here. You could plug it into your calculator, or you could try and do it through intuition. I leave it to you to decide what would be best to use. So let's look at one more example before I finish. This is given x minus 2 as we sit here. This means that now we've been given a factor. We don't have to check it, we know. We're now trying to find the other factors for that function. So let's roll. We draw our favorite shape, the inverted L, and we fill it in as we go. So that's 2, minus 11, 17, minus 6. Don't be too daunted by the numbers. The numbers are all there for you to work with. Just be careful with your method. That's the main thing. So here, and we know that's 2, because that x is minus 2, whoops, sorry, there's a minus in there, over 1, and that's 2. That gets plugged in right there. So we drag the 2 down as we started, and there we go. We times 2 gives us 4. That leaves us with minus 7 when added together. Right? Minus 7 times 2 gives us, what is it? Up 14. Oops, minus 14. Don't forget that. Signs are your biggest catch here. Be careful. That minus this gives you 3. 3 times 2 gives you 6. And there's our 0. Yes, so glad we could get that. So once we have that, let's rewrite it quickly in terms of f of x. So f of x now again equals x minus 2, as we were given that as a factor, times 2x squared minus 7x plus 3. And what you know, you factorize that again and you're at the end. So let's do a quick review. And remember, the quadratic function is what you're going to use to find the final polynomials for that function. All good? Let's quickly review what we've just done today. We're given a polynomial in the form of a funny standard form. Not very useful, so we factorize it to get it to that. How do we do that? First step, remainder factor theorem. We show that this is in fact a function, or in fact a factor of the polynomial we've been given on top here. Once we've got that, we use synthetic division. As you stated below, I'm just copying it as we have it here. Straight through, that gives us our function here, which we can rewrite over here, and then factorize using the quadratic function or any method you find useful. Remember, this is not me telling you what to do. This is me giving you the options of what to do. And from there, that gets us straight back here, and that's the winning solution. Okay guys, well, that's all I can give you for polynomial factorization. But if you have any questions, ask your teacher. Until then, see you later.